your FID, right, is just this numeric identifier, right? It's just kind of this anchor point so that everyone on Farcaster has this ID number. But that's not really useful for communicating with people, right? If I want to send a message on Twitter, I'm going to use somebody's name, right? I'm going to message at Chase on Twitter rather than look up your numeric identifier in the ID registry contract and figure out how to send a message to you, right? So these FIDs are really useful at the protocol level when you're constructing a message. They let us define the interactions in the protocol in terms of this numeric ID, which is more useful for kind of machines to read than human names, right? But your name on the Farcaster protocol is actually an ENS name. So you can bring your own ENS name, you can register that and associate that to your FID, which can be used on the protocol as your name. So if I'm referring to someone, I can refer to you by ENS name, or you can use a Farcaster provided identity. So it'll be like chase.fcast.id. And we're working on making those fully compliant ENS names as well.
On this episode, we spoke with Horsefacts, who has built a ton in the space. He's working on Farcaster right now, talked about their idea of like sufficient decentralization and how they think through like what to put on chain, what to put off chain. What did you pick up from this episode, Chase?
Yeah, I think another really interesting piece here was just when to abide by standards and when to build your own sort of implementation. So we talked about Farcaster's identity system, along with some of the on-chain and off-chain stuff. So this is just an episode full of really, really interesting and great little golden nuggets. So hopefully you enjoy it as much as we did. We are here with Horsefacts, who is an independent Solidity engineer and general EVM enthusiast. Horsefacts, thanks so much for coming on the show.
Yeah, thanks for having me.
GM.
You've had some legends on this podcast so far, so I'm really, really honored to be here.
Another legend on this episode as well. Very excited to dive into all of the work that you've done across the space. You've had your hands in a lot of different projects, so can't wait to dive into that. But before we do that, maybe you can give a little bit of background on how the hell you got into crypto and what brought you to where you are now.
Sure, yeah, that's always an interesting story. I think I'm technically class of 2017, I guess, but I feel like I kind of wandered slowly backwards into the Ethereum ecosystem over a few years. But yeah, the story is that the first project I worked on was an EVM indexer, a project called Vulcanized DB, starting in like late 2017, I guess tail end of like the ICO boom and kind of the run up there in 2017. Yeah, at the time I was working for a consultancy building software products and met Rick Dudley, who was the sort of inventor of Vulcanized DB, kind of mad genius figure, in my opinion, around the Ethereum community. But yeah, he came to us with this idea for building an Ethereum indexer, which became this project called Vulcanize. So yeah, back at the time, you could think like this was kind of when the graph starting to evolve and people were starting to build on top of the graph. There were kind of a few competing indexer products at the time. I think everyone in the space has built an indexer, it seems, whether it's for their own custom application or kind of trying to take their own swing at this, like, let's build the one indexer to end them all generic indexing type product. But Vulcanize was a really, really cool product, in part because it was trying to do a few things that other indexers didn't do, including indexing all Ethereum data. So we would take in every block, all the events in that block. We forked Geth and added some modifications there to get access to storage key changes and storage value changes, so we could track storage changes from block to block. You could watch contracts and sort of decode contracts and events. And the idea there was to build an indexer that could be open source, could be run by anyone, would sort of store kind of full take Ethereum data you could get back in a reliable, provable way, data about the contracts and events and information that you were interested in. And this was in a time before we had like great APIs for a lot of this. Geth tracing really has evolved and parity tracing, and some of that tooling has gotten way, way, way better over the last several years. But at the time, we had to do kind of a lot of low-level stuff in order to get access to that data. Anyways, yeah, worked on this project for a few years, kind of solving a lot of problems I think many people in the space have solved, event decoding and indexing and all of that. I guess the claim to fame for Vulcanize was that the Maker team used it as their internal indexer for MCD. So when they were building MCD, a lot of kind of internal tools at Maker relied on the system and used that for like liquidation dashboards and internal alerting and things like that. There were a few different indexers within Maker at the time, as there are in probably any DAO, right? There are a few different solutions to every problem, but we were one of them. And so we're involved through that, basically through the launch of MCD. And kind of woke up after a couple years of working on this project and realized I had lived this great sort of full stack experience of the whole EVM, right? Like we were running an archive node in order to run the infrastructure for the system. We had maintained this fork of Geth and learned a lot about internals there. I was spending a lot of time like reading the MCD contracts in order to decode the events that are in those Maker contracts and learned a lot about Solidity through that. And so, I'd been in an Ethereum sort of hobbyist, in 2017 and prior to working on this project. And for a couple of years, I wasn't maybe totally convinced, Ethereum is going to stick around. This project, it was just an interesting technical project, right? But I kind of woke up after a few years and realized I've learned a lot about this ecosystem. Became really, really interesting, increasingly interesting after working on that for a while, and got slowly pulled deeper and deeper. So it was really interesting in that I kind of was like off in a corner working on this project of my own for a little bit, and maybe like not super focused on the whole ecosystem, but kind of woke up after a point and realized, wow, I've learned a lot about the space, and the things people are building out there are really cool.
That's always kind of a magical moment where you're like, whoa, I actually know way more about this space than I imagined. And now it's applicable to a bunch of other things, which it seems like from there, you moved into a lot more consumer type of applications.
Yeah, it took me a long time to start writing smart contracts and writing Solidity. And I attribute that to having worked with the team at Maker, who have this incredibly high engineering standard, reading those contracts. I consider, that original Maker team and the folks there superheroes in the space. And, they have such a high bar for testing and verification. The DeFi ecosystem can be, so adversarial, so high stakes that it can be really scary to write contracts. And so I felt for a long time like there's a very high bar to clear that right in order to write reliable Solidity, and had to kind of walk that path and learn that myself to get into that. I would attribute like kind of the NFT boom and on-chain art, and some of that was really, really great for me as a developer, because I gave myself permission to kind of experiment, right? And suddenly there were these things you could do on-chain, right, that were not like a DeFi protocol that is handling tokens or money, or so high stakes that you have to think really carefully about that. So that was a good place. And I built all these projects right prior to that, smart contract projects that kind of were on testnet or never got deployed or whatever. So kind of cautiously wandered my way into working on smart contracts and more consumer-facing stuff. But yeah, since then, I've worked a little bit more on some user and consumer-facing stuff. So Seaport, a little bit of support for Party DAO, and I've been working on Farcaster most recently.
Yeah, so it sounds like you kind of used some of the more consumer-facing, maybe we'll say less high-risk types of domains in crypto to start exploring what it looks like to write Solidity and actually develop smart contracts.
Yeah. I don't know if anything is less high risk. It's the most adversarial, most intense, most kind of perfectionist programming environment I've ever worked in. And something that's really exciting about it. I think for a certain type of person, that's really fun and exciting. For a certain type of person, that's like terrifying, and you turn around and run away for good reason. But yes, yeah, something like that for sure.
Coming from the Web 2 world of like, if you make a mistake, it'll cost the company money, but there is not literal money like on the lines of code that you're writing in the same way that there's that literal correlation now. Like even at Seaport, it might not be a single contract that is like an Aave with like a ton of TVL, but the code that you're writing matters a lot to the people that are using it. So it's high stakes.
I'm curious, in the context of moving from VulcanizedDB towards more of these consumer-facing applications, what are the different paradigms in terms of just thinking about consumer versus, and even being more involved in the Maker ecosystem? Like, I'm curious if there are different paradigms or approaches to smart contract design in the sort of DeFi world versus the more consumer-facing crypto application world.
I think a very interesting thing about the kind of Solidity and smart contract space is it's young enough that a lot of the patterns that we have and practices that we have in Solidity development are still kind of folklore, right? Like there's not a patterns book, right, that you can go grab and read on kind of patterns for Solidity development. We're getting there, I think, right? Like we have open source examples of past protocols and code and things we can go look at to establish some of those. And like we have names for patterns in the ecosystem now, proxy patterns and vaults, and we have standards like tokens, right? But in some degree, the ecosystem is still young enough that we haven't given names to all these components or these things that we have in the ecosystem yet. And to the question of, I guess, differences in consumer facing versus like DeFi facing. Yeah, I guess I think of Maker, right? The ecosystem is old enough now, right, that we have had kind of several waves of developers and several waves of kind of designs and patterns for some of these contracts, right? And so, yeah, I think about Maker, and like the thing I love about those contracts is kind of the old school. I think of those as old school, and their kind of old school simplicity and immutability of those contracts, kind of removing as much as you can from the design of that system or that interface. I don't know, I guess Maker is kind of, notoriously known as a system that has lots of moving parts and interactions, right? But I think the developers of that system did do a good job of kind of removing everything they could to make that as simple as possible, even if there are many components that need to interact. Since then, yeah, we've gone through maybe some successive waves of design of contracts, right? We have upgradable contracts and that whole wave of design and patterns there in terms of designing those protocols. Something I've been thinking about more recently as well is like, as was sort of reflecting on this recently, working on the Farcaster contracts, is kind of the influence that even front-end tools can have on the design of your contracts under the hood, right? Like I sort of had the old habit of, let's write a function with, multiple primitive parameters, right? An integer, an address, something like that, right? Because it used to be really painful, right, to work with structs and Solidity. On the Solidity side, when you're developing in Solidity, it can be kind of painful to construct structs or things that have nested arrays and things like that. But actually, we have these tools now on the front end, right? VM was the example here where it's actually really nice to work with structs, right? And so you can have this sort of influence and this interplay between the way that your front end interacts with the contracts on the back end and this kind of design of the front end and your contracts. I don't know. I think it really depends on the scale of your system. The answer in in everything, Solidity and software is almost always it depends, right? It kind of depends on the scale of your system and what you're integrating with, right? For like a simple single contract application, maybe it makes more sense to kind of design for the integration with your front end. For a larger system with more components and more things interacting, maybe you should think more carefully about kind of the core design of your protocol in those contracts. So
yes, what I'm hearing is like at a high level within this new paradigm, simple is better. But as we have built more out and as our tooling has improved, we've been able to allow for more complexity, whether it's complexity in the communication between the smart contracts in the front end or just like complexity in the protocols themselves. And I think Farcaster in particular is a cool area of not only do we get to do neat new interactions that don't exist in like DeFi and just like regular NFT ecosystems, we can start to use this as a platform that we're communicating through and that we're just like using to socialize. I think Farcaster has a design mantra of like sufficient decentralization, where like you only put on chain what needs to be on chain, and then you take off chain what you don't want to have on chain. Can you talk a little bit about that? And actually, maybe even before we dive into that, can you give just a high level about what Farcaster is, in case any of our listeners haven't played around with it yet?
Yeah, sure. So Farcaster is a protocol for building social networks. It's a decentralized protocol, consists both of an off-chain protocol for storing messages and what are called hubs. This is an off-chain peer-to-peer network repository that gossips messages between hubs and stores message data for the network. And an on-chain component, which is mostly used for identity. There's a distinction between Farcaster, the protocol, right, and then clients of that protocol. So you might have seen Warpcast, which is kind of the major Farcaster client right now, which is building it's sort of a Twitter-like social network interface.
Got it. And can you, for listeners that might be more aware of like other sort of distributed social network platforms, how would Farcaster Hubs compare to Mastodon? What do they call it? Federated spaces?
Yeah.
How would those compare?
Yeah, so the big distinction is that on Mastodon or a federated site, sort of each Mastodon server is storing its own copy of certain messages, and then they're federated, right? So if you need to get a message from some other server, you can go reach out to somebody else's server to get that data. In a Farcaster hub, every hub stores all the messages on the network. So it's not a blockchain, but it does use sort of cryptographic signatures over the messages and Merkleized CRDT format where each hub stores all the messages and you can verify. If you're running a hub, you have all the data at any particular point in time.
So you touched on some of the architecture pieces. I think it would be interesting to get a little bit deeper into what that looks like. So it sounds like identity is sort of the piece that lives on chain, and then some of the other pieces around messaging are what lives off chain. Maybe we can start with identity living on chain and then go into some of the messaging pieces off chain.
Sure. So we mentioned this mantra of sort of sufficient decentralization. One thing I like about the design of Farcaster is that I think they've been very pragmatic in designing, choosing what to put on chain and what to keep off chain, right? So basically all the messaging data, all the kind of high frequency data that's generated by users on the network, that all lives off chain in the hubs. We can talk about that in a sec. And sort of the minimal necessary state is what lives on chain. So we have, I think, 4 or 5 contracts that are on chain. Those are on Optimism mainnet now. So we just migrated up from a testnet that was on Goerli to Optimism mainnet. So we have an ID registry. So this is basically your Farcaster ID or FID. So that associates an Ethereum address, your ECDSA key pair Ethereum address with just a numeric identifier. So you can almost think of that as like an NFT minus, right? Like it's just kind of a numeric index in this ID registry, which your Ethereum address points to this identifier. Those are transferable, sort of have limited transferability, so you can transfer those to to other addresses. Contracts can own FIDs as well. The big thing there is that the receiver of an FID has to accept that transfer, so you have to sign for it. But if you're a contract that supports 1271 signatures, or you can sign messages, you're able to receive and own and register FIDs on chain on Optimism.
So just a quick follow-up question. So this is not using like a 721 or 1155 standard, right? Like this is Farcaster's own sort of implementation of, to your point, like NFT minus.
Yeah, it's even simpler right now. And the previous design, they actually were 721s, and we thought about that design as well. But yeah, we want to keep the Farcaster ID registry basically as simple as possible. So it's intentionally not a 721 for some reasons there.
Interesting. I mean, just as like a side note, and then we can get back into the on-chain and off-chain elements. In my mind, I'm thinking also about Friend Tech, which in a similar way is not actually abiding by standards. They're just sort of building the minimum viable version of what they need in terms of the contracts and what's on chain in order to like have users have an experience that makes sense. And so in my head, I'm kind of like, interesting observation that some of the more, I don't want to say evolved, it's not necessarily the right way to think about it, but after a few iterations of these social applications, it seems like abiding by standards might be overrated. I don't know. Maybe that's the wrong take.
I don't know if I agree with that. I think there are places where standards are really important. And actually, this is a good segue. Maybe we can talk about another one. So your FID, right, is just this numeric identifier, right? It's just kind of this anchor point so that everyone on Farcaster has this ID number. But that's not really useful for communicating with people, right? If I want to send a message on Twitter, I'm going to use somebody's name, right? I'm going to message at Chase on Twitter rather than look up your numeric identifier in the ID registry contract and figure out how to send a message to you, right? So these FIDs are really useful at the protocol level when you're constructing a message. They let us define the interactions in the protocol in terms of this numeric ID, which is more useful for kind of machines to read than human names, right? But your name on the Farcaster protocol is actually an ENS name. So you can bring your own ENS name, you can register that and associate that to your FID, which can be used on the protocol as your name. So if I'm referring to someone, I can refer to you by ENS name, or you can use a Farcaster provided identity. So it'll be like chase.fcast.id. And we're working on making those fully compliant ENS names as well. So we're going to use an off-chain resolver where we can issue you, if you want to bring your own super decentralized name, you can use your ENS name, associate that to your Farcaster ID. If you want to use the slightly less decentralized Farcaster provided off-chain resolver, you can register that and you'll get one of those by default. This was actually an example of a case where we weren't using a standard for that earlier iteration of the contracts. We had our own kind of name registry, ENS-inspired kind of thing. But over time, we realized, yeah, the ENS standard is really useful for this. We have a perfectly great name system that we can use, and let's just adopt ENS as the standard. And so we were able to migrate from that kind of custom hand-rolled name system over to ENS. So yeah, I think it's a matter of kind of choosing where and when you want all the capabilities provided by a standard. And like, yeah, in the case of Farcaster FIDs, we decided, at least right now, we don't necessarily want everything that comes in that bundle of adopting the standard, right? Like transferability from person to person, listing those in the open on marketplaces and things like that. Like all those things that are built on top of making that NERC 721.
Yeah, it's kind of interesting. Like I'm trying to think about the generalizable rule of thumb there. And I think you're right in the sense that I don't actually know that there is a generalizable rule of thumb so much as it is like for any given moment where you can decide to abide by a standard or build your own, you basically need to do a cost-benefit analysis. And it's kind of interesting because to some degree what you're doing is like deciding whether or not you want to adopt sort of like the physics of an existing thing versus build your own. And, of course, the physics, quote unquote, around composability and all of that comes with a whole slew of other weird things around like, okay, well now people can trade this and now it's compatible with all these maybe, AMMs or whatever it might be. So yeah, I guess I'm curious, like, it sounds like maybe there is not a single rule of thumb for whether or not you want to be adopting existing standards, but I'm curious if that feels like it resonates with you, or if you do think there are a few things where they're very clear, sort of ways to assess whether or not you want to adopt a given standard or create your own.
There's always a trade-off there. Yeah, I guess we're just going to come back to it. It depends again, right? But like, there's always this question, right? Of are you going to be the first person to trailblaze a new standard as well, right? Or do you want to adopt something that's been used and adopted by the community already?
So into that ID, then I'm starting to see where it is needed as sort of the glue. You want something that is disconnected from an individual address so that it can be transferable if you change your Ethereum address, but you also need it to be able to like be the glue to a human readable ID, whether that's the Farcaster generated one or an ENS. So you need it to be able to like move and attach to these different things. And probably it needs to be flexible enough that in the future you can maybe attach more things to it or just like change the shape of it to be whatever it is that you need. Does that seem accurate?
Yeah, that seems right. So there's a key registry contract. This is where you have your FID, you have your name, right? That's an ENS name. So a key registry associates public keys to an FID. So you can basically add and revoke keys on chain. Really simple registry, just kind of a mapping of which FIDs are associated to which public keys, and kind of a generic schema in there for adding potentially different types of public keys and different types of kind of metadata that's associated with those public keys. And this was another place where we looked at some standards and drew inspiration from some there. There are standards out there for other kind of on-chain PKI registries, and we looked at the design of the stealth address registry, right, which is an interesting IP out there as well for kind of PKI infrastructure. But yeah, ultimately this key registry is quite simple. It's just an on-chain registry which associates what's called a signer to your FID. And this is maybe the bridge between some of the on-chain components and some of the off-chain components. So within Farcaster, right, your FID is owned by your Ethereum address, your ECDSA key. Signers, which are what the keys that are authorized to produce messages on behalf of your identity on the protocol, are EdDSA keys, which live off-chain. So if I sign up with a client like Warpcast, for example, they'll generate an EdDSA key pair for me, register the public key of that key pair with the key registry, and now that key, which the client has created and is holding onto on my behalf, is authorized to post messages on my behalf on the network. So you delegate authority to a client app in order to post messages on your behalf, and that uses EdDSA for some technical reasons. The off-chain protocol is all built around EdDSA keys. So through the key registry, you can register those keys, basically adding and removing applications which are authorized to essentially post to Farcaster or produce messages on your behalf. And the key registry is the link there where storing those public keys on chain, hubs can read that key registry, the off-chain components read that key registry and know which keys are authorized for which users at which time. And that helped us solve some synchronization problems that was actually stored off-chain before. You'd sign a message off-chain in order to authorize or revoke signers. But actually putting that on-chain turned out to be a place where using a blockchain for that state and using a network that we know is kind of globally synchronized helped us solve some problems in kind of the key adding and revoking infrastructure off-chain in the hubs.
That's a really interesting aspect here. Is that type of delegation for a client to be able to post basically on behalf of you? Is that common, do you know, among other, like, does Lens, for example, do something like that? Or is that sort of unique to Farcaster?
So certainly, the use of EdDSA and off-chain signers, I think, is somewhat unique to Farcaster. I actually don't know that much in detail about how Lens does delegation. I know Lens does a lot with meta transactions, right, where you can authorize or delegate certain addresses to post on your behalf. In general, though, Lens is like much more on-chain, I think, than Farcaster is, right? The design of Lens is much more kind of everything goes on-chain. Design of Farcaster is more, let's store everything off-chain. I'm a Web3 social maxi. Like I'm on Lens, I'm on Farcaster, I'm on Blue Sky. I think these are all cool. These are all really interesting different points in this design space. Like I like them all. I hope they all succeed. But yeah, they're all sort of at different points in terms of the design space and the trade-offs. And there's some cool stuff I think you can do on Lens in terms of like that on-chainness of the protocol as well.
I'm kind of glad that like we're seeing all of the different options play out, because I think that's kind of what we need in order to be able to see what works and what doesn't. While you were talking, I was looking at the difference between ECDSA and EdDSA. It sounds like so EC meaning elliptic curve, ED meaning Edwards curve, and there's like a trade-off in, it seems like, performance and like implementation. Is this like too in the weeds, or can you speak a little bit about like why choosing EdDSA for this component?
Yeah, I think the short answer is like, yeah, EdDSA is faster for some reasons to verify. I'm not an EdDSA cryptography expert, but yeah, the idea is basically just it was a better choice for these off-chain components that didn't need to interact directly with Ethereum. No, Ethereum is like, is built pretty deeply around ECDSA, right? And so anything that kind of where you need to do a signature on chain with Ethereum, or you're interacting with an Ethereum address or account, that kind of by necessity needs to be ECDSA. Although there are lots of interesting like proposals out there, right, for new precompiles and new, especially with account abstraction and stuff coming out there that might be changing for Ethereum. But at least for now, Ethereum is still pretty tightly coupled, I think, to ECDSA implementation.
It sounds like it's like a further example of like doing the thing that makes the most sense for the context that it's in. Like just because Ethereum uses ECDSA everywhere doesn't mean that like our off-chain thing necessarily has to do that. Let's use something else that if it fits better. Yeah, that makes a lot of sense. I'm curious. So it sounded like there was recently a migration with the deployment of the V3 contracts and that you had to migrate data from the existing contracts to the new ones. Can you talk about that a little bit?
Yeah, this was really interesting for me. And this was actually the first major system that I've designed that would be L2 native. So we migrated the V2 contracts from Goerli, right? We had a running network, right? People were using Farcaster. Maybe not everyone knew that it was based on Goerli, right? But all the Ethereum contracts were all the blockchain anchored, Ethereum anchored stuff was deployed to Goerli for V2. We gave a revision to those contracts for V3, introduced kind of the new design we've been talking about here with those few contracts, and migrated everything to Optimism. Yeah, and there were a few interesting things there. Like, first of all, the fact that it was possible to migrate in the first place, right? Like, I think L2s have opened this new design space that's very interesting where trade-offs, right, that simply weren't possible on L1 are possible now, right? So we had 20,000 users. We migrated the data from the Goerli contract to Optimism, right? We just sent 20,000 transactions to register everyone, read the data out of the old contracts and write it. Like, yeah, I haven't done the math on like what that would have cost on L1, but would have been prohibitively expensive. I think we spent 1.5 ETH or something like that to migrate everybody up to Optimism.
Did that process in itself come with like its own weird edge cases and like problems? I think when you think about sending like 2 or 3 transactions over between networks, it's like one set of constraints. But when you're talking about 20,000, I imagine that like gets complicated, right?
It was pretty smooth, I have to say. I mean, part of that was because we designed that migration system into the contracts, right? So we had batch methods, right, where you could specify multiple users at a time, and of course, like we tested the script and the system pretty heavily to ensure it all checked out. But yeah, I think like adjusting to life on L2s has been interesting, right? There are on the developer side, you have intuitions that are sort of hard won from working on L1 for a long time around what to optimize and how to write your code that are like sort of totally out the window when you're working for L1, right? Suddenly L2 gas is a rounding error, right? And the only thing that matters is the cost of your L1 call data. And we're not necessarily all in the habit, right, as developers of optimizing for call data, right? We have optimized for gas for so long that those are really, really hard won and kind of deeply ingrained patterns, I think. Yeah, as well as tools that sometimes interact with L2s. You have to figure out how to estimate gas and figure out how to do these calculations of L2 gas versus L1 call data costs and some of those things where working on that frontier, those tools are maybe not quite as developed as using some of the tools that are native to L1. So yeah, there can be some challenges there.
So you kind of spoke to some of the challenges. And then I'm curious on the flip side of that, like, are there certain design decisions that you feel like are unlocked from an L2 perspective? I mean, certainly the ability to migrate 20,000 transactions is one. But in terms of other sort of paradigm shifts, I'm curious if there are certain things where you were like, holy shit, this is actually possible to do on an L2 and we could have never done this on L1.
Yeah, I mean, certain cost decisions, you're able to make a trade-off in terms of the value of, say, your time versus the efforts in continued optimization or adding additional features, something like that, right? Since it's simply not an option on L1, right? The decision is always to optimize, right? It's always figure out how we can make this more gas efficient, always figure out how we can reduce the cost. There are conversations maybe when you're working on L2 that are like, if we save 20 cents calling this function, is that worth investing, this amount of time and effort and money in that optimization? And that's much more like, I guess, questions in kind of conventional software development. But those are conversations that just simply aren't even possible on L1. I don't know that I have the answer to that, right? And like even L2s are this interesting ecosystem, right, where those long-term costs are subject to lots of different variables that are in flux, right? What is the cost of L1 call data going to continue to be? What is the cost of L1 gas going to continue to be? What happens when L2 block space suddenly is in higher demand than L1 block space? There's a lot of uncertainty to design around there, I think.
You've written quite a bit on testing, and I'm curious if any of the approach to how you think about testing shifts from an L2 or when you're on an L2 versus an L1.
Yeah, that's an interesting question. We have this amazing blessing of EVM compatibility and EVM equivalence between many L1s. And fortunately, that means that in terms of testing what you're building at the EVM, like the bytecode level, we have, I think, pretty good, those tools carry over, right? And so maybe those tools and techniques carry over. When we're thinking about testing for gas profiling, definitely is kind of a dark art and a challenge, right? That changes a lot. Maybe that's a form of testing, right? But that's not so much the sort of testing that's about correctness of your code or design of your system as much, even though that stuff is really important. Yeah, and I don't know. I mean, we are starting to see in some places these divergences, right? Big shout out to Matt Solomon's EVM diff tool, which is like a great place to go explore, and seeing these things where some L2s don't support push zero yet, and but mainnet Ethereum does, or certain sort of drift in some of these features and configurations across EVMs. I think testing will be important in those cases, right, where it's not necessarily guaranteed that you can take some contract that's deployed on one network and go deploy it on another.
Yeah. I mean, even I'd imagine like the testing for the batch transactions of moving towards an L1, I'd imagine was quite robust. Though, I don't know, maybe there's a world in which it was not effective and you waste 1.5 ETH and it's like, whatever, you have as many shots at it as you need. But yeah, I think that's really interesting.
Yeah. I mean, so like a thing that's like still continues to amaze me and be really, really cool and exciting about working in Solidity and working in the EVM is like just the determinism and the ability to simulate transactions on the EVM. Like, I think this is one of the things that I found most like continues to kind of continuously blow my mind as, a former like Web2 developer who has come into this space, right? Like thinking about what it would be like to do that in, I don't know, some payment system I was building in a web app, right? Like, okay, let's like fork the state of the world and like we're going to fork the state of everybody's credit card balance and like, make this request to the Stripe API and see exactly what would happen if I'd done this. Like so much of the time that you invest in these systems that you build in the web, right, is around accurately simulating, right, or mucking and stuffing these dependencies that you have and trying to create this system that is this model, right, this model that you're testing that is like analogous enough to the real world that you can feel confident in it. And you have this capability in the EVM and in these deterministic systems to say, just fork it, just see what would happen. And that's really cool. And so many intuitions that I had like coming into the Solidity space have changed like because of working with that property of the EVM, right? Like probably many Solidity developers have gone through this, right? Like you start like writing mocks and stubs and things that are these kind of carryover patterns from testing in the old world. And then you realize you can actually rely in a much more production-like meaningful way on your real dependencies and simulate those real dependencies in a useful way to you as a developer.
Yeah. Consensus on the state of things and determinism as a combo is pretty damn good.
Yeah. Yeah, so to the point of like, the migration, right? Like we were able to see exactly what would happen before we ran those transactions, run checking out, did we migrate everyone exactly as we expected? Run an off-chain hub, for instance, make sure those picked up all the events exactly as we expected, and the state of the data was exactly what we expected afterwards. Yeah, that's a pretty cool property to be able to have in your system end to end.
Yeah, I want to linger a little bit more on testing, but like zoom back to some of the work that you've done previously. I know at Seaport, you worked on a fuzz testing library. I know you've written a lot about invariant testing. How do you think about and prioritize these different approaches to testing? And is there like, I've seen the Web 2 testing pyramid of like unit testing on the bottom and like integration testing at the top. Do you have like a similar way that you think about and prioritize which type of testing you would do first and then what you do as you like have additional time and flexibility?
Yeah, that's a good question. And I think the conventional testing pyramid is probably still a good guide to how to prioritize. My answer in general is like, you should do it all. Obviously, that's not like that's not necessarily, let's say, like a resource informed answer, right? Where we all have to make trade-offs between where we're going to invest our time and energy. And yeah, I don't know if that determinism of the EVM necessarily changes the way you would structure that testing pyramid. For me, yeah, I do more fork testing and simulation testing in the EVM because I think I can than I would in other types of development, right? Like this notion maybe of like an integration test is kind of less clear in Solidity what that is and where that lives. But yeah, in general, I'm a big fan of unit testing for design, right? As a mechanism that gives you continuous feedback on the design of your system as you're building. And in like the most extreme case of that is like TDD, right? Really, really rigorous TDD where people are writing their tests before they write their code, that kind of thing. I think the correctness benefits of that maybe are less clear in Solidity, right? Like it's probably not the best mechanism to ensure correctness. You should be relying on fuzzing and formal verification and writing a good spec and higher level tools for like that correctness. But I do think it has implications for like getting fast feedback on the code that you're writing and the design of your system. I think that's especially important in smart contracts where you have like a lot fewer opportunities to get that right? So that kind of write a test, write some code, see how it works, kind of like red, green, refactor conventional cycle of TDD can be really useful to give you more iterations on the design while you're building a system. So I think you need to do both like top down and bottom up, right? Really good systems start with high level thinking about the spec and the invariants and the design of the system from kind of top down. Unlike the way maybe people in Web 2 like to do it, right? Saying, okay, we'll just build it bottom up, like go purely, totally agile because we can deploy 100 times a day and fix any mistakes that we make in the system. We can't do that with smart contracts, right? You have to have that top down thinking about like, what is the spec? What are the invariants of the system? But as you're building that from the bottom up and thinking about like iterative design, I find that very useful, right? And like, yeah, I do believe in this, like this sort of adage that things that are difficult to test right are probably poorly designed, right? Where you feel pain in your tests, you need to think about the design of your production code and your system. And so kind of getting that continuous feedback is very, very useful, I think, as you build. So always start with unit tests, right, for me. I think one thing I think is extremely cool about tools like Foundry that have become really popular in like testing and Solidity is the ability to kind of upgrade your tests as you go as well, right? So you can start with writing unit tests for some specific conditions. You can kind of upgrade those into a fuzz test, right? Parameterize those, define properties about the unit tests that you've written as you're kind of exploring the design space and build those up. In some cases, even turn those into like a symbolic test or plug those into a tool that does, more spec-based kind of formal verification. That workflow, I think, is very powerful to say, kind of start simple with these, thinking about these individual cases, and then kind of boost and upgrade the power of your tests as you go. It's one thing I thought was really cool about DApp tools. We don't quite have the like symbolic execution integration for Foundry just yet, but DApp tools used to have this, right, where you could change a test from test underscore to check underscore. It would run that test as a symbolic test. We have some pretty good and increasingly good tooling for that like plugs into Foundry. There's some stuff from the runtime verification guys. There's Helmos and some tools that kind of pick up on your Foundry tests, and we'll inject that. And I hope soon we can have that kind of same workflow though of like upgrade your tests as you go.
Yeah, I like those few rules of them also, which seems to be like always be testing. If you are finding it really difficult to write tests, then you should probably take a look in the mirror, and escalation basically of your tests is sort of the way to go. And hopefully tools just get better over time for that.
Yeah. Maybe another interesting thing here is that there are forms of testing in the UVM ecosystem that like I rarely used as a Web 2 developer, right? Like I didn't do a lot of formal verification of my web applications. But systems, I think, in smart contracts, right, are small enough and simple enough that in many cases you can apply those tools. You can write a spec that describes all your invariants. You can keep your system small and simple enough that you can actually use these forms of testing that are much more difficult to do in other ecosystems. And yeah, I think we should be embracing those and using those as much as we can as well.
What does using formal verification look like for writing your Solidity test? Are there tools, or is this more of a thought process? What does that actually translate to?
Yeah, I think it's both. And I am still learning these tools myself. I'm not a formal verification expert, but I do like to use the tools as a practitioner, right, to the degree that I can. It starts with thinking about invariants, right? You'll see this term come up in lots of testing, right? Invariant testing, symbolic execution testing, formal verification, right? It's about what are these properties that should hold true about your system at any given time. And then thinking through, how can state transitions within that system affect those properties? What should always be true no matter what? Within some bounded context, right? Maybe it's the whole system and the interactions between those contracts. Maybe it's a single contract and its state at a particular point in time. And sitting down and thinking through those. And once you have those specified, right, you can define those as kind of like logical mathematical properties, which you can then verify using a tool like a bunch of different formal verification tools, using like, the Satora prover, where maybe you write those tools out in a specification language, or Helmos, right, where you're doing symbolic execution and sort of defining the properties about your system in a more kind of unit testy style syntax.
Cool. All right. That's super helpful. This was like a lot that I'm going to revisit this portion of the episode and just like mine it for testing knowledge. This was really great.
As we wrap up, I'm very curious. So one of the questions that we've been asking people is basically like, what tools are you bullish on or have found most helpful? Could be libraries, could be tools, could be whatever. Yeah, what are you most excited about? What do you think people listening can and should explore?
Yeah, I mean, maybe this is just salient because we were just discussing it, but I think the symbolic execution and formal verification tools have come a long way in terms of their ability to be used by sort of individual practitioners, right? So I've been experimenting with the Satora prover recently. That's a really cool tool. With Helmos as well, which is a symbolic execution engine that plugs into Foundry tests. And these are becoming much more usable, I guess, by everyday folks in terms of writing specs and kind of building these into your day-to-day development workflow. Yeah, of course, Foundry and like the fuzzing and testing and variant testing capabilities that has built in, that entire suite of tools has transformed the way that I test and build applications. I think folks who aren't using that yet should absolutely check that out. Maybe all the way back to the indexing conversation, I'm really excited about kind of the emerging Rust ecosystem of tools and products. Like I went to the Rust Day demos recently, and like there's just been so much growth in that. Thinking back to what we were doing with Vulcanize and the information we were trying to extract out of Geth and the hacks that we had to put in place to kind of get access to the data that we want. We have this emerging ecosystem where some of the components of the stack have been abstracted in ways that are really useful, and you can kind of build it at different layers in order to extract data that you're interested in and do both real-time, pull real-time data and kind of historical analytical data. And I think that sort of modular abstraction of different components of the Rust DPM stack is really exciting because there's some things we can build on top of that too.
Yeah, I got to meet you at the Rust Ethereum event, and I have to say it did Rust pill me more than I had been. I've always been like, oh, cool, this is super fast and neat. But just seeing how much the Ethereum Rust ecosystem has emerged was pretty promising.
Bullish. Bullish Rust.
Bullish.
And also abstraction, because over abstraction is the name of the pod. Well, Horsefacts, it was so wonderful to have you on. Where can people learn more about you and all of the wonderful work that you're doing in the space?
Sure. So I'm Horsefacts.eth on Farcaster. Let's do that one first. And actually, I'm spending a lot more time there. There's a great conversation around folks who are building on the EVM on Farcaster. I'm also ETH_call on Twitter if you want to find me there. Still spend time there. And yeah, you can check out kind of my professional backgrounds and projects and things at terminally.online, which is my website.
Which is a great website.
Yeah, that's a great name.
Thanks.
I'll +1. The Farcaster signal to noise ratio is great. Right now, it's like there is Ethereum people there, and like that's what it's for, and that's what it's about. I mean, over time, I imagine that's the idea is to evolve that. But compared to my Twitter feed is like a wasteland at this point. It's very sad.
Yeah, Elon has done a real number on Twitter, but it was so fun to have you on Horsefacts. Thank you so much for coming on the pod. We'll also link some of the testing tools that you mentioned in the show notes, because I'd imagine people are going to want to dive into that. So thank you so much for all of the wonderful conversation.
Yeah, thank you both.